start.
Hello, I'm Miles Tails Prower. We will learn about infrared and visible spectrum. As before, we have discussed about many applications and its 11 types of frequency from extremely low to extremely high frequency. Now we begin with infrared spectrum. Its frequency ranging from 300 GHz to 400 THz. Its wavelength ranges from 1 mm to 750 nanometers, that is 0.75 micrometers. Although less than 1 mm, infrared is electromagnetic radiation with wavelengths longer than those of visible light. It is also dependent on its temperature levels that can detect heat. These further applications such as a pseudo-color image depending on its temperature level. From black to white, the colors which come in order like black, blue, purple, red, orange, yellow, and white. Similarly, the thermography usually detects radiation in the long infrared range of the electromagnetic spectrum, which is also dependent on the temperature level. One other application is the night vision. In case of darkness, the night vision camera comes on but it appears like a green light on the source of the screen. When this happens, there is an insufficient amount of light if there is a power outage. On the other hand, we discuss about visible spectrum. You are already familiar with the colors ranging from red to violet. Its frequency ranges from 400 to 750 THz. And its wavelength ranges from 750 to 400 nanometers. Besides, its wavelength is becoming less than 1 micrometers. When the colors change, we put these checkpoints for the terahertz frequency: 400, 480, 500, 530, 600, 660, and 750. Similarly, for the wavelength in nanometers, it goes in decreasing order: 750, 620, 600, 570, 500, 450, and 400. Its colors are red, orange, yellow, green, blue, and violet. The application usage is about prism, which divides the white light into rainbow colors. Red is the least deviation and violet has the highest deviation. Other application, as we discussed earlier about Doppler redshift, as the sun comes towards the observer, is a blue shift. If it goes away, then it's a red shift. From 750 THz and above, there will be a lot of ionizing radiation, such as extreme ultraviolet, soft X-rays, hard X-rays, and gamma rays. This would pose to severe health hazards and affects world. That is 1 petahertz and above. Its wavelength goes less than 300 nanometers. For example, the sun shows an extreme ultraviolet composite image, showing a solar flare and coronal mass ejection. X-rays, for example, used in the bodies in medical hospitals. And gamma rays, for example, emitting during nuclear fission in nuclear explosions. That's how the entire electromagnetic spectrum works. When you increase the frequency, lesser will be the wavelength. So this proves the formula for frequency and wavelength relations. Like, comment, and subscribe now.